All right, so this is section 6-6, and now we're moving into a new topic, but it is related to polar coordinates. Now we're going to be talking about vectors. If you've ever taken a physics class, you've heard about vectors and magnitude before, and this will just be a new topic if you haven't had that background before. But a vector is an amount or a quantity that involves magnitude and direction. So magnitude is like a number, it's indicating a length or size, and then direction is, pointing in a certain direction. A scalar is just a quantity that involves magnitude but no direction. And then a directed line segment is a segment that has been assigned a direction. These are the terms that we're really going to be familiar with and using in this section. This is a representation of a vector. We're starting here and going in this direction, so PQ has a direction. This is the terminal point, and then this is the initial point here. So it's going from here to here. It does end, it doesn't go on forever, but it has a direction. Now the magnitude of this is the length of this line segment here. It's the distance from P to Q. And then we have this direction here. So let's look at some different examples here. We're looking at these 4 different cases. Now these two vectors, vector V and vector W, they have the same magnitude and the same direction. They have the same length and they're going in the same direction. Now vectors V and vector W have the same magnitude but different directions. So this one's going in this direction, this one's going off this way a little bit. Notice that these two vectors here are parallel. To have the same direction, they have to be parallel. Now, these two have the same magnitude but opposite directions. Now, opposite directions also means parallel, but they're going different ways, or the opposite ways. So notice we've had same direction, different direction, and opposite direction. And now this last example, these are going in the same direction, they're parallel as well, and they have different magnitudes. Their length is different. Okay. So we're going to look at an example, and we're going to be given that we want to show vector u and vector v have the same magnitude and the same or that they're equal. So in order to show that they're equal, that means we need to show that they have the same magnitude. And we want to show that they have the same slope. Now, I haven't given you any vectors yet, so this information I'm drawing right now is what would be given to you. So we have 1, 2, 3, 4, 5, 6. This is vector v, starting at the origin, ending at 3, 6. And generally when we write vectors, we write it with this little arrow above it. That just represents it's a vector. And then vector u will start at -3, -3. And go to 0, 3. And my graph is not perfect here. And this is vector u. Alright, so that's what's given to you in this problem. And we want to show that they have the same magnitude. So we need to find the magnitude of v and the magnitude of u. And the way you find magnitude would be distance. What's the length of this line? So we can use the distance formula. We have 6 minus 0 and 3 minus 0. And that gives us the square root of 45, which is 3 root 5. And the magnitude of u, we have 0 minus -3 and 3 minus -3. So we have 0 minus -3. And 3 minus negative 3. And that gives us a square root of 45, which is 3 root 5. So we know that they have the same magnitude, the same length, but we need to make sure that they're going in the same direction. So what we need to find now is their slope. So we're going to find the slope of u and the slope of v. So the slope of u is 3 minus negative 3, y1 minus y2, and x1 minus x2. And we have 0 minus negative 3. And that gives us 6 over 3, which is 2. And then for the slope of v, we have 6 minus 0 and 3 minus 0. And that gives us 6 over 3, which gives us 2. So they have the same magnitude, they have the same slope, and what that means is since our magnitude, I'm just going to abbreviate, and magnitude, direction, they're pointing the same direction, and slope are the same, then vector u is equal to vector v. And that's how we would show that two vectors are equal. I'm going to go ahead and move up and look at our next example. It says we can multiply a vector by a real number. And so if I have this vector right here, vector v, and I multiply it by 1/2, then that shortens it. It's going in the same direction. It's starting and ending here, and it just means that the magnitude is cut in half. If I multiply by 2, that means I'm doubling the magnitude. So it's still going the same direction, same slope, but my length is twice as long. And then if I have it multiplied by a negative, that flips the direction in the opposite direction. It's multiplied by 1/2, or 3 over 2. And it's not going in that direction anymore. It has flipped directions and now is pointed this way. And so that's what we can do graphically or visually with our vectors. Now we're going to talk about a few different things here. If I have a scalar, which is just a number, and I multiply it by the vector, then that's called a scalar multiple of the vector. That's what all these are, a scalar multiple of the vector. 1/2 is the scalar, v is the vector. 2 is a scalar, v is the vector. So this is a scalar multiple. Okay. A multiple of a vector, if k is positive, then it's in the same direction. If k is negative, it's in the opposite direction. This is all the same stuff we just did here. But now let's look down at adding vectors. So if I have vector u plus vector v, we can do this graphically. If I have, let's say, this vector here and this vector here, and let's say this is v and this is u, then what I can do is I can place them so that they start at the same, let's see, I'm actually going to white this out here. I'm going to adjust this a little bit actually. Let's do this in color. This will be a little bit easier. If I have vector v and I have vector u, okay, if I'm going to add these two vectors, I need to line them up. So this is v, and it's exactly in the same spot. And then u needs to line up so that it starts where v ends. Still pointing in the same direction, still the same magnitude. And that resultant vector, these two vectors added together, is the start of V to the end of U. That's this vector. Okay, so that's how we would do things graphically. We can also subtract vectors. If I have two vectors V and U, and I'm subtracting them. So let's say this is U, and this is V. And if I want to subtract them, that's the same thing as adding a negative. So if I have V minus U, that's equal to vector V plus negative U. Well, if that's the case, then negative U is just pointing the other way. And we can set up our new U so that we're adding a negative. So V plus negative U, the resultant vector is this piece right here. Start of U, or start of V, end of U. Okay, so that's how we're representing this with the vectors. Now we can look at vectors in the rectangular coordinate system, and this is where we actually see them be more useful. If I have unit vectors, kind of like when we talked about the unit circle, those are vectors of one unit. The magnitude is 1, or the length is 1. Okay. Now I is a unit vector whose direction is along the positive x-axis starting at 0, 0. And J is a unit vector whose direction is along the positive y-axis starting at 0, 0. So if this is my coordinate plane, this is going to be I, and this would be J. If this is 1 and this is 1. So those are our unit vectors. We can write all other vectors in terms of these. So it says vectors in the rectangular coordinate subsystem can be represented using I and J. If I have some vector V, we can represent it with I and J. So how do we do that? How do we represent vectors in terms of I and J? Well, if it's going from 0, 0 to some point AB, then what we can do is A is the coefficient on I and B is the coefficient on J. Okay, if it's starting at 0, 0. So A and B are then scalar components of vector V. A is the horizontal component and B is the vertical component. And the magnitude of vector V is going to be using the distance formula of A and B, again, assuming it's starting at the origin. So let's do a really quick example. If we have vector V and we have this unit vector 3i and 4j, and we want to represent it on the coordinate system, we have 1, 2, 3, 1, 2, 3, 4. So negative 3, 4, plotting that point right here. That's our A and our B value. And our vector is this right here. That's a vector V. And it also asks us to find the magnitude. So the magnitude of V would be negative 3 squared plus 4 squared, which is the square root of 25, which is 5 units. And magnitude always describes length, so we want to make sure we have the units on there. And we're going to go ahead and stop here, and this will be the end of part 1 of this section.